How does temperature gradient drive conduction and heat transfer? Imagine holding a metal spoon in a hot cup of coffee. You notice the spoon's handle stays cool at first, but eventually it warms up. Why does heat move from the hot coffee to the cooler handle? The answer lies in something called a temperature gradient. A temperature gradient is simply the difference in temperature between 2 points within a material. When one part is hotter and another cooler, this difference creates a kind of energy imbalance. Molecules in the hot area vibrate or move more vigorously because they have more kinetic energy. Molecules in the cooler area vibrate less. When these energetic molecules bump into their less energetic neighbors, they transfer some of their energy. Think of it like a game of billiards where a moving ball hits a stationary one and makes it roll. This chain of collisions causes energy to flow from the hot region to the cold one. The bigger the temperature difference between 2 points, the faster this energy moves. If the temperature is the same everywhere, no net heat flows because there's no energy difference to drive the process. This movement of heat through a material is called conduction. It happens because molecules or atoms in solids are packed closely together and can transfer energy efficiently through vibrations and collisions. Metals are especially good at conducting heat because they have free electrons that move energy even faster. The rate at which heat moves depends on the temperature gradient, the material's ability to conduct heat, and the size of the area through which heat flows. This relationship is described by a law called Fourier's law of heat conduction. It states that the heat transfer rate equals the thermal conductivity of the material times the cross-sectional area times the temperature gradient. In simple terms, if you increase the temperature difference or use a material that conducts heat well, more heat will flow faster. For example, copper is used in heat sinks because it conducts heat quickly, helping to cool electronic devices. Insulators like foam or rubber have low thermal conductivity, so they slow down heat transfer and keep things warm or cool. Understanding how temperature gradients drive conduction helps us design everything from cooking utensils to insulation for buildings. It all comes down to molecules moving energy from hot to cold regions because of the difference in their energy levels. The larger the difference, the more energy flows, making conduction an essential part of how heat moves in our world.